Hello and welcome to the Slingshot channel. Oak Harvest Edition. No, I mean the winter is really early this year and we had lots of snow, and the snow brought down a branch from one of my oak trees, and I decided to harvest all the forks in the broken off branches, and here they are. There's about 20 of them, and of course some of them are really big, which I love because it gives me all the freedom to carve slingshots from it. I always like to use the natural tree forks because they're just much more solid, since the fiber direction is automatically split by nature. So those make slingshots that are just way more solid than board cuts because of the fiber direction. Some of them are rather interesting, like this one here. If I remove the middle one, this could be a really wide fork. And this one here actually has two slingshots in it. Oak, of course, is a very hard wood. It's one of the hardest woods that you can find here in Germany. And as you see, these are pretty ancient. I mean, there's a lot of like moss on it and growth and so on. So, but still, of course, it's wet because that was a live branch. So when I make a slingshot, I have to dry all the forks out in the microwave anyway. And you also see that the wood is very bright, and that's very typical for like Middle European wood. We don't have really dark tinted wood here, and the grain of oak is just so dense that it also doesn't respond very well to like oiling and you know, just other kinds of you know, wood color. I already made one slingshot from it. This is my 6 circles design. Why is it called 6 circles? Well, because it's actually designed with using 3 completely different circles. Like there's a circle here, like a radius, and one here. That would be a really big circle. There's circles here and here. And of course there's 2 circles here and then the lower one here. So it's designed entirely based on 6 circles with 3 different diameters. So as you can see, the wood is really bright, but also super dense. It doesn't soak up the linseed oil well, so therefore it's still very pale. And as you see, the fork wasn't quite big enough, so I had to repair a part of it, which was still like the bark, with a cut-off piece from the same wood. I just glued it on and then filed it flush. And as you see, the slingshot is really nice. And I can assure you it works great, even though I can't really shoot it well here in the shed and out in the rain. I'm too old for that shit. What else can you make from oak wood? Well, you can of course make nice wooden knives from it. The only problem is the edge retention. You know, the sharper you make the edge, the easier it will go, just because it's still wood, even if it's hardwood. So is there a way how to make this happen? So can we make a knife that is functional, really functional? It cuts and it, you know, it stabs and everything, but it's completely undetectable by metal detectors because there's no metal in it? Well, I think so, if you use the right stuff. So I'm using this here. This is actually some kind of a glue. So it consists of 2 components. There's like a powder, and then there is some kind of super glue, very thin. So and then the thing is that if this super glue reaches this powder, a little bit of smoke evaporates, it stinks enormously, and it instantly hardens, and then it gets super hard, like rock hard. So if I wanted to make a little shank with a nail and a piece of wood, it's very easy. I would just simply put the nail on the wood here. Then I would take the powder and just start by pouring a little bit over the nail. Then I'd use a little bit of this glue here, and it automatically soaks it up. So it's very smelly, but it instantly hardens, and as you can see, now it's already fixed to it, and now I can just simply pour some more over it to make it more solid. Okay. So now you can see that I completely kind of covered this with it, and it's really solid. I mean, I can now, you know, really do something with it, and it really is glued on super hard, and this feels rock hard. And it is. So even if I use like a file, you know, it feels like really I'm filing through some stone. It's not like metal, it's more like stone. So you can file it, but you know, it's still very hard. Even the sound, I think, resembles stone. So let's test the sturdiness of our little shank here in the vise. Okay. It's holding up really well. Let's go ahead and file some more. Okay. I've used the power file. Yeah, that works. Okay. Now let's do the hard test and hammer down on this here, see if we can break it off. No. See, I'm now bending the nail, but I'm not breaking it off the handle. That is a wonderful miracle glue, don't you think? So the question is, can we use this to form an edge into a knife that is more solid than the wooden edge would be? Yes, we can. Here is a leftover piece from the oak wood, and what we're now going to do is we're going to try to give this an edge. And we simply do this by sawing a groove into this here, filling it up with the magical glue and let it harden, and then we try to sharpen it. So this is the result. As you can see, we now have some glue in here, and now we just have to shape this so it forms an edge. As you can see, I'm not sure if it's really razor sharp, but it looks kind of sharp. Yeah, so let's see if we can cut into paper with it. Yeah, sort of. Will it cut into wood? Well, let's take this little wooden dowel here. Oh yes, it does. See? Ha. I'm carving wood with wood. So can we make a better knife, like a knife that somehow resembles a real knife? Yes, we can. Here it is. So, the invisible to magnetic detectors wooden knife with an edge made from glue. Let me show you its features. As you see, it's made, I mean, the shape is just because I used a piece of the oak wood that had an angle into it, so I just did my best to get something out of it. Now the edge is not super sharp just because I don't want it to be so sharp, because the sharper it gets, the more vulnerable it gets. So, and now we will have to test it against ballistic gelatin, what else? So here is a block of ballistic gelatin, nice and firm. But of course we need to give it a little bit more realistic touch. So we take this really strong, like window cleaning leather that is simulating skin, even though it's probably much stronger than skin. And we're taking this dirty little cotton rag to simulate a t-shirt. Over the gelatin here. Okay. Here's the skin and the t-shirt. Let's see if we can stab it. So as you see, it cuts through both of it, and of course it went into the ballistic gelatin. Now of course just the ballistic gelatin wouldn't be a problem at all. So we can just do this as often as we want to. And of course, you know, I think like skin and t-shirts are sort of overrated too. So this is completely reproducible. So how about cutting? Can we cut through the ballistic gelatin with this knife? Well, let's try to cut off a slice. Okay, that seems possible. Okay, blade isn't long enough for a whole cut, so we'll turn this around. And here is our slice. Super bland, but edible. Is it dead now? Probably not. So let's simulate some underwater action with the scuba Eschinger. Now it's dead. Now there are knives on the market that are sold as, you know, not having metal in it, like ceramic knives, and also like plastic knives like Ivory and so on. And I'm sure that they all work fine, but typically they are like legally obliged to also put some metal into it so that they would be detectable by metal detectors. No, this homemade one of course isn't. Will they now put me on a no-fly list? I hope not, because I'm going to visit the SHOT Show in end of January, so I'll be in Vegas then, if they let me fly. And I promise I'll leave this at home. Anyway, I hope you like this, because that's it for today. Thanks and bye-bye.